in this triangle, we're given that the two triangles are similar to each other, but we aren't given what corresponding sides are. So we can actually choose what we want the corresponding sides to be. And this is a max-min problem where we want to find the difference between the greatest possible perimeter and the smallest possible perimeter. So we can find the greatest possible perimeter and the smallest possible perimeter. For that to happen, essentially, we need to find out one simple fact, and that is if the similarity ratio of two triangles is A to B, then the ratio of their perimeters is also A to B. And so if the ratio of the two sides is A to B, and then the ratio of the perimeters is A to B. So what we can do is we can say, okay, well, what's the greatest ratio we can have between these? And that is, we take the small side 12 and set that as corresponding to 36. And so the ratio of the sides would be 12 over 36, or 1/3. And the ratio of the perimeter as well, this perimeter we already know, that's going to be 12 plus 18 plus 24, which is 54. And then the ratio of the bigger one we don't know, but we know that the ratio of the sides is equal to the ratio of the perimeter, so we can set this equation up, cross multiply, and we get the large perimeter as x equals 162. If we want to find the small one, then we look for the smallest ratio, and that would be taking the biggest side and putting that corresponding to 36. And that equals 2/3. And then we set that equal to, well, again, we know the perimeter is 54. And we need to find the perimeter of our smaller triangle. So we solve this equation, and we get 2x equals 3 times 54 is 162. Divide both sides by 2, and you get x is 81. So the largest perimeter is 162. Smallest perimeter is 81, and we utilize, so the correct answer to this problem is 81 because that was difference. We utilize the fact that the perimeter is an equal ratio to the sides.